and finalize your goal, what you are going to do. We'll wait for 5 minutes.
We can just talk to the.
Your group member coming?
Yes, the group. Maybe group in first. Because there are 3 people here already.
So you start with group A? Group
E. Group E. Right? Group
A is here?
A is here. There's 1 people.
Yeah, 1 people? Okay. You can sit, no issues. So you all are working on chassis design.
Yeah, we are talking about chassis design.
Chassis design. So initially. So initially you have shown us about Amazon's robot.
Yeah.
Okay.
Amazon.
So now the professor in your first comment, he has told you that you have to evaluate the whole structure design and try to evaluate how much maximum load it can bear
From the current robot.
from the car,
Okay.
from our robot, the actual robot which is there. So maybe you, if you want, you can take the design files from ARIA, the lab. You can ask
Okay,
them
okay.
to take the design files which is already there, so that you can re-evaluate that design using the load analysis, static structural load analysis, using ANSYS, and check how much load it can bear. Okay?
Is the load, I mean, for the load, is it like?
Like the load bearing capacity of the chassis, the car,
Okay. The whole chassis,
the
right?
whole chassis, yeah.
Or the load that it can carry is like, you know, the extrusion.
No, not that.
Oh, just the chassis.
The whole structure.
Okay.
Because you are dealing with whole structure.
Yeah.
You have shown in the yesterday the whole structure.
Yeah.
So you may require for the whole structure,
Okay.
not only for that the transmission arm.
Okay.
So you will deal with whole structure because transmission arm is a part of the structure.
Okay.
Is a part of whole structure. So the bottom car has to bear all the transmission loads. You know, if it will be taking something from the rack, some 20 kgs from the rack, this 20 kgs will be transmitted to the car because it will move by taking that load. So all the load will be transmitted to the car. So car should be strong enough to take all the transmission loads.
Okay.
It should not vibrate. So all you have to check it. So you all will deal with the structural analysis.
Did we also need to create a new chassis or?
Might if you want to suggest a new chassis,
Okay.
you can. Right now you are having a chassis. We put the components. Maybe you can check the center of gravity through the ANSYS.
Okay.
There is a feature you can find out the center of gravity by making all the components in it. So you can try to redesign it if you want, but evaluate the structural analysis first of the group STEM. So we are discussing for group A. You all are A. Yeah. So initially you have given us about Amazon's robot of taking the loads. Now professor wants you, in the first comment, he suggests that you can make a structural analysis on whole frame. Is it so? You're doing that?
Yeah, we are doing that.
Yeah. Structural analysis of chassis and the structure of the car. Okay? So my intention is, initially you can evaluate what is existing. Like what the car design is there, you can take the design from Tommy, we can give them the design.
The design or AMR?
CAD file, AMR CAD file.
Yeah, we can give that. I have already put
Okay.
the PPT on the FB group. They can check it on it's the link because I can upload on the website.
Okay.
So I just put a
Already
link
given.
on
So
the.
you can take that design, evaluate that existing design, and propose the new one if you want. First, evaluate what is that. Check how much load it can sustain using ANSYS. So evaluation till now you have not done. You have done something? No.
Just last time. Looking on PPT.
Only PPT. It's not up to mark. You have to do more.
Yeah.
Yeah. So first evaluate the existing design and try to incorporate some new design or some reallocation of the parts.
Yeah.
Like motor is here, battery is there, you can change it and try to make it more feasible. You do that initially. Anything else you want to ask?
I will close
We got
it.
it. Yeah, we got it.
Got it. So
Because
you are clear with what you have to do?
Yeah.
No issues now?
Okay.
Not yet. So you have to redesign the chassis and the structure part. Don't think about gearing, transmission and all. You have to bear the transmission loads to the chassis. Okay? Means anything comes, whole weight will be bear by the chassis. So you have to redesign the chassis. Mainly. The application layer is not so much important for you because that is a load for you,
Yeah.
which is beared by the chassis. Okay? So anything else? Any suggestion from anyone to them? No? This is a discussion class, so no need to worry. Just we are discussing on your comments and improving your final goal. What will be your final goal? Okay?
Okay.
So if anyone have a comment on any other group, you can freely tell us. No issues. So group 1 is clear. Have you seen your comments? You asked Tommy about your comments? No, you should. You should ask that which are my comments so that we can improve in the next round. So your comment was maybe you can focus on improving how much AMR can carry. Of course, evaluating how much it is most carries, means how much load it can carry. So that's the structural part, static structural load analysis on the chassis. That was a comment from Professor Lim. Why the can I ask you one question? Why the chassis should be strong enough?
Carry more load.
Huh?
So you can carry more load.
Any other answer? Anyone? Why the chassis of the car is so heavy?
So the center of gravity can be lower.
You know, while picking something, there will be an vibrational loads. Okay? When you pick something, maybe it is a heavy load. If 20 kg load is picking and going somewhere. So all this load should be transmitted to the bottom. Bottom should be strong enough to bear the vibrational loads. So that's why the chassis and everything is heavy. The part of the bottom is always heavy to bear the loads, to bear the transmission loads. Because it will move up, going forward, going backward. So all this transmission creates some vibrations. The gears in the application, all this creates some vibrations. So to withstand all these vibrational loads, the chassis is always they are making it heavy. And also the chassis bears the application, that's why. Okay. So I think group A is clear to their vision that what they have to do. Anything else? No? So the next group, B. So you are dealing with forklift.
Yep.
So you are implementing forklift to the AMR design. Okay. mechanism to put the cylindrical objects to the machine.
Yes.
You are changing that mechanism, or you are making the AMR to one more application to it, like a forklift with this AMR. Two in one, or you are just making this car with forklift.
We're changing the design.
You are changing the application design.
Yeah.
The car is same, the
Yeah.
application design is now for forklift.
Yes.
Okay. Have you thought about the transmission?
The
How
what?
it will work? How will lift up?
We haven't changed that yet. We currently sticking with the original, the original lift. We didn't change that yet.
You're not thinking about that?
In the future, we haven't worked on that quite yet.
Because future is very near.
All right. Okay.
Future is within 2 months. You have to complete it.
All right.
So, because your fork is not going to the bottom.
Well, it is. Well, we're working on the design.
And plus, yesterday Professor Tino has told us,
Yeah, retractable.
yeah, it should be retractable because the space in the area is very limited.
Yes.
So how you will deal with it?
I've come up with 2 designs. Maybe we will have more. So we might do some analysis and see which one is best.
I'm checking that your comments, anything has to be shared with you. Okay, there are only comments with the same which you have done.
Okay.
So go through it and reconsider your design so that it can have higher degree of freedom. Okay? Anything you want to ask?
Because like we need to make the form, so I just like going down straight to the bottom or just
If you are thinking of the same mechanism, like this application, it's not going to the
Yeah,
bottom of the car.
it's-
It's in the height
yeah.
because all the cylindrical objects are put in the rack,
Yes.
and it's a height from the ground in the
Yeah,
industry. So they design according to that. So maybe your forklift is designed for
yeah.
not
Not the
to
bottom.
pick up the object from the ground,
Yeah.
to pick up the object from the racks.
Yeah.
Or maybe you can put height. It can go some height instead of going from the ground, taking from the ground. It can pick the object from some height.
Right.
Maybe you can think on that.
Okay.
The application layer should be long enough.
Yep.
Or maybe you can try rotatable forks like this here instead of making rotating car.
But the car can rotate.
Car can rotate, yeah. So better to make it
Vertical.
vertically height, not go to the bottom of the ground.
Right.
That's good.
Okay.
Anything else? But you have to think of the retractable system.
Yeah.
That's a unique feature. That's a good suggestion.
Okay.
Because still right now the forklift doesn't have retractable. No.
Not really.
I don't think so. So if that feature will be there, then it is good.
Right.
Because if the space constraint is there in the industry, it cannot hit something else,
Yeah.
any machine components. group B, anything else? No? Okay. Any suggestion to group B? No? Any criticism to group B? No? You should suggest each and everyone. Okay? To come to group C, he is not here. It's a
Yes.
one-man army.
Yeah, he's not here.
I think it is clear. You
Yes.
know everything that
Yes,
you have to go for analysis for the plate
the
first.
different analyze for for different plate and
Different plate and
maybe
different
and NCs for different kind and
check the strength analysis.
yes.
Load bearing capacity.
Okay.
Group D. Anyone from D? D.
D.
One. Where are your members? Oh, you are dealing with the shaft.
Yeah.
But you have your first proposal, you have told about shaft, second proposal, again you told about shaft. But you have to deal with whole gearing mechanism and shaft system, complete. So why you are choosing again one shaft? Because shaft is only for transmitting the load,
Yeah.
transmitting the load from motor to under part.
I know.
So why you are choosing only one?
Because we don't have much time to do it.
But now you have time to do
Yeah.
it. So you have to choose whole gearing mechanism. So complete mechanism. So and check how much load it can bear. Or maybe you can have a fatigue life analysis. That after how much rotation or revolution this shaft can damage. That can be done in the ANSYS easily. Okay? Any suggestion for group D? No? Group E, I think all are here. Group E. So you have the mechanism for stable platform. Whether this can be applicable to the existing AMR?
Apply to the AMR problem to make the platform stable.
In the existing AMR? My question is, if you can apply this balancing platform to the existing, which you have seen in ITRI, Italy, can be applied to this design? You getting my question?
Yeah. Sure.
How?
You mean to apply in real life?
Yes, I am asking that.
Make
Can
an
your
area-
balancing platform can be applied to the existing AMR, which we are showing?
We can make a prototype to apply in real life, but I don't know if we can really apply because we don't have the resources to do so. Like we don't have the raw with us, so I don't know.
So you will propose a design
Yeah,
and we'll do some analysis on that,
yes.
okay?
Maybe we can make a small prototype.
Or
but
you can
not-
make a small prototype,
Yeah.
that's good. So you will doing a Stewart mechanism for balancing the platform. Or you think on some other concept? Have you think on some other concept rather than Stewart mechanism?
No.
you seen the paper which Professor told you? Shreks. Maybe I can do it.
I already shredded the one of the.
Have you seen that paper?
Yeah.
Parallel mechanism.
Yeah.
So that was also a balancing platform, but they have made with 3D printing. But still that have some issues. We have published a paper, but still that have some issues. Have you studied that which type of parallel mechanisms are there? I think that paper describes many parallel mechanisms in introduction part. You have not seen the paper?
I don't know.
So you study more on parallel mechanisms. There are many parallel mechanisms available which helps to make the platform balanced. Not that?
It's not sense.
Is that it's not a, it's red. It's paper, right?
Yeah.
I swimmed the swimmer, but then say that it's not the same. So maybe I can take it again and have send it to.
This paper has a design and controlling of a self-balancing platform mechanism on 3 RCC spherical parallel manipulator. So this paper you can read it. It's on balancing platform. We have used spherical parallel manipulators. Spherical parallel manipulators for balancing the platform. Have you searched about 3 RCC, CRC, CCR spherical motions for balancing platform? No? So you read this paper, you can get some ideas about various mechanisms to balance the platforms. Okay? You don't know about that?
I don't have the paper.
Haven't sent it.
Okay.
His groommates haven't. Her groommates haven't sent it. He's still sending number.
okay, you can read this paper and we'll discuss more at the last. So next is
Is EF.
F. The group F. The bearing design.
Yeah.
So, which component you will, which bearing you will select from the AMR? The already existing bearing you have selected. Ball bearing, any specification you have taken? No, just you have drawn on your own specification. But don't do that. Take the specification which is used in AMR. Take one bearing, make the company, which is the bearings company, you can get the specification. Draw that specification into the CAD file and then do the analysis. You'll get the exact specification and try to do the fatigue analysis. Fatigue life analysis. How much, after how many days it can damage. If you want some steps, one of our student has Faris, I will give you the files.
Okay.
I can give you the files. He has done the bearing analysis, fatigue analysis on the bearing for a reactor. Maybe you can check how to analysis. I can share you some files, how to do that. It will be easy for you to do the bearing analysis, fatigue life analysis. But you have to check the specifications which are already existing in the AMR. Then compare with the wire design with the same specification. You getting? You have designed the bearing not as per standards. You have just designed the bearing using some rare specification, or you have taken the exact bearing which is used. Have you taken the bearing which is used? The specification of the bearing? Group E. Group F.
Group E.
F.
Group F.
Yesterday what you have shown, the ball bearing design, what is the specification of it? What's the diameter of the ball bearing design?
We haven't defined.
You haven't defined. You should have defined whole specification of the bearing initially, which is existing. Do analysis on that and then with the same diameter propose a wire bearing. And again do the analysis on the wire bearing and compare it. You getting?
Compare the difference.
Huh?
Compare the difference.
Compare the difference. Then your results will come, that which is better. Either maybe you can get good results or maybe you can get something new. Something. But the specification of the bearing should be as per standards. Like the diameter, then only you can get the exact results. If you take the normal specification or any diameter, you cannot compare properly. If you want, you can take the specification from some companies' websites, like FAG, FAG, the bearing company, or NSK. You can go to the website, they publish the specifications of the bearing, like how much the ball rollers are there, how much diameter the casing, how much diameter the internal radius, what's the clearance. So this all will be your tolerance and fits, limits and fits of the bearing. So you have to consider all these things. Right now just you have drawn a casing and the ball rollers and compact, but not as per specifications. Are you getting? Anything you want to ask?
prepare your report.
So one more group is added, group G.
Okay, so I will be reporting my project report so far from this survey. And so I'm doing the analysis about the omnidirectional AMR. It's from Professor Patel solution, and they have like two layers. First one is the chassis, and the second one is the application layer. So for the chassis dimension, it have 900 millimeter in length, 820 millimeter in width, and 500 in height. And the weight is around 164 kilogram. And the material it used is carbon steel. For the application layer is around 900 millimeter in length, 820 in width, and 790 in height. The weight is around 260 kg. The materials it used is carbon steel for the layer, like the black ignis, and aluminum alloy for the lifting baffle. So my goals when this analysis is over is I'm looking forward to maybe make the overall weight more lighter and increase the overall carried weight. So far, the maximum one is around 10 kilos. Maybe I will looking forward to adding around 5 kilo to 10 kilos. And I will do that by maybe further structural analysis about the overall layers and maybe potentially material changes. So far, I already started the structural analysis, but I haven't done yet. Maybe in the next progress report I will give you further updates about it. So yeah, this one is for the reference. Yeah, I think that's all.
So you will try to increase the load from 20 kg to 25 kg.
Yeah.
Means you are focusing on application layer. On specifically on the ball screw and the gripper mechanism. The related to gripper mechanism. Have you think on that how you do that?
I'm still thinking. I haven't think about it, so maybe first I will do the analysis of the structure first, and then this is all about.
Don't go for material change. I think it's not. But it's not feasible to do that one of different materials because material is already constant. Making is a constant. Maybe you can think on the gripper design, the part of the transmission of the gripper like ball screws, analysis on the screws. Or you can come to the application range. See that is a part of the plate. Yeah. No, this is a plate. That is the part, and that is the ball screws, the long one. Maybe you can check this part because this part has been designed by some company for us. Maybe you can select this part, the gripper one, only the gripper, and rethink on it and improve the load bearing capacity. Don't go for all. It's then more.
No materials change.
Yeah, don't do for material. Okay?
Thank you.
Someone haven't because there are some student labels or he didn't scan the test, and I will see the time. If you're over 9, maybe 25 or 20, I will calculate your score speed. Maybe some discount, maybe some people, but maybe the student that attend on time maybe is 1 point, and if you're late, maybe I give you 0.7, maybe I think. They will have some discount for your today's test. So please be on time in the future class, okay? Okay, everyone? Okay. I will still give you a point, but maybe have some discount from your test score, okay? So make sure you'll be on time in the future.
So I think everyone's goal is now clear. Okay. So once again I repeat. Okay. So group A will doing on the chassis redesign and structural load bearing analysis. Okay. The group B will be a B forklift, implementing a forklift on the current AMI design. It's clear? Yes. Then group C, he will be doing on the plate. This Francis. He's doing a analysis on the plate. He will try some topology optimization for the plate. Like right now, it's an hard steel plate. Maybe he can use some honeycomb structure or something to reduce the weight of the machine. Group D. Group D, shaft. They will do the analysis on shaft and the gearing mechanisms which is used to lift up the plate and lift down the plate. Okay? So you have to consider all mechanisms, not only shaft. Group E will be in the balancing platform. You will design a balancing platform using any mechanisms which either this paper can give or something else, or Stewart mechanism, whatever you want. Group F, for the bearing. So you have to consider, group F has to consider the bearing specifications which is used in the AMR initially, and then compared with another bearing, the wire type. Okay? And the G, yeah, the last one, G. So we'll do the structural analysis for gripper mechanism, maybe a linear guideway or the ball screw, which is used in the gripper mechanism. Okay, it's clear? So your part is only focused on the gripper mechanism. I think everyone is clear with that topics. Any issues? Any questions? No? If you want any guidance, you can come to the lab. You can meet Arya or Janice. They have built this machine. So you can come and you can talk to them if you have any queries related, focus to them. Or you can share the paper to them also.
The AMR paper.
Yeah.
I have already
Or you
sent.
can-
I have.
you see?
I have already sent a Facebook as
One paper we have published related to this AMR. Last
another paper. Your teacher just told me to send a PPT.
You can share the paper, it's online.
Okay.
He will share you the paper.
So that can share on the. They don't have anything. I can just
Yeah,
share on the.
it's an open access.
It's
so
open
you can
access,
share
okay.
It, share it.
Your
No
teacher
issues.
had told me that the PPT can send on the website, so I just send the link. On
Yeah,
the
this also you can share with either. I think yesterday I've shared with you. Yeah, so you can share with them in
Okay,
a
okay.
personal one.
Okay.
So they can share with
I
them.
will stick on the
Or you
FB
can
group.
open it here. I can show you
Okay.
the link. It's an iRobotics.
The links.
The iRobotics channel. Search iRobotics. Yeah,
So that is can.
No, it's open
So I
access.
didn't. I just sent to one query. I didn't send on the website. Or you can send me the PDF and I will put on the FB later. Yes, I can. Line this one.
Maybe you can create an ID and download the paper from here. It is this paper. You can directly download from here, but it asks to create an ID. That's all. But it's an open access, so you can download from this here.
So you just create a account for this and you can see this.
It's open access in the
Okay, and you can see this on this
Or
paper.
I will share you, no issues.
Okay, you can share. If you want to see on the website, you can just use this. And also share on the FB maybe in the afternoon. Okay. Website, I use our lab website.
So in this paper you can get some insights of about the AMR easily. You can read it, what the material is used, what the analysis is still done, what is not done. Okay? So what are done the analysis which has done in the paper, you can try some new one. Like we have just done only 2 or 3 analysis. We have not done too much analysis. So we need you guys to do it more. So to get it, to get the new, get more results. Okay?
Okay.